All right, today we're going to continue with our intersection and union that we did in the last lesson, and then we're also going to look at the principle of inclusion and exclusion, which sounds fancy, but it's pretty straightforward and something that we've already kind of talked about anyway. So shouldn't be too much today. So first, to start with, let's review what we did yesterday with the circles, because sometimes these questions show up on diplomas and they can be a little bit tricky. So I want to make sure we review this one a little bit. So first of all, I've got the just the regular A and B overlapping circles, and we're going to do all of these different shadings just to make sure we're clear. So the first one, it's asking shade A circle, so just A. So A would be everything that's inside A, so that's pretty simple. And the next one, and it would work the same with B, right? We could do all of just the B circle if we wanted to. So the next one on here is, what is B prime? So what is the complement of B? So that would be everything outside of B. So that would include all of the A circle that's not in B. But what you got to remember is it also includes everything in the universal set outside of B as well. Okay, so everything would be shaded except for the B circle. So be careful with those ones. And then the next few are a little bit more difficult. So we did these ones yesterday. So what would the A circle slash B, so remember that was what's in A but not in B. So that would be all of the A circle but not B. So that would be, that's the Pac-Man sort of shape. So all of A, but we don't cover the B. And the one next after it is, what is B, all of B without A complement. So sometimes these complement ones can be tricky. So let's do the without the complement first. So all of B without A, so that would be sort of the B Pac-Man, right? So it'd be all of that circle. So then the complement then would be everything else. So it'd be all of the box, all of the A circle, and so on. Okay, so in this case for letter D, B slash A complement would be all of the red area shaded like that. Okay, so those are some of the ones we did yesterday. Then we started looking at union and intersection as well, and that's the main ideas that we're going to worry about for today. So E is A union B. Because I typed these in, I don't have a union symbol, so when you're going through these notes, if you see the small letter U, that's actually my union, and the small letter N would be our intersection symbol. Okay, so just kind of imagine when you see those, that's what I meant for those. Okay, so for letter E, we want A union B, so that means all of the A circle or all of the B circle, or both. So remember with union, it's all of the circles, A and B, and the overlap. So you want to do the whole thing. Then for letter F, it was A intersection B. So remember that intersection means and, or, that's where the overlap part is. So A intersection B when would be just the overlap. Okay, so it should look just like that. So A intersection B would be just those two overlapping parts. And the last one, letter G, A union B complement. So it'll be the same as E, right? E was A union B was just all of the circles. So in this case, the complement then would be everything outside the circle. So it'd be all of the box without the circles included. Okay, so once you get the hang of those, they're pretty straightforward, and just be careful that you kind of remember what each symbol means and what it means in English and what it would mean in terms of the shading. Like I said, diplomas, they quite often throw questions like this at you. Okay, we'll move on. So we're going to look at what the principle of inclusion and exclusion means today, and it mostly deals with union. So what we're going to do before we get to what it is and understand the notation, which can be a little bit confusing, we're going to do an example, and that'll help us sort of understand how it's going to work. So the example I got here is, suppose there was 30 people in your class, 18 of those people are going to take the bus to school, 14 of those people are going to drive to school. Some will do both, right? Depending on, some days you might take the bus, some days you might drive, whatever. And then there's going to be 3 people that do neither. So that would be people that walk or get a ride or whatever. Okay, so we'll do bus, school, and our bus, drive, and then neither. So it really doesn't matter which one we place where, so we'll just kind of start. So if 18 people take the bus, remember that'll be 18 people for all of circle A, and then 14 people drive, so that's 14 for all of circle B, and then 3 do neither, so that would be outside the circles, and then we have a total of 30 people. So that's the other key number to remember. Okay, so let's do the math on this to make sure we kind of have it all figured out. So if there's 30 people total, we have 3 people that do neither, so really then we only have 27, right? If we go 30 minus the 3, that'll give us the 27 people that do both, but then if we go 18 plus 14, that gives us, what's that work out to, 32. So that means there's 32 people that do bus, drive, or both, but we know that there's only 27 people total that we can work with, right? 30 minus 3 gave us 27, so that means now if we go 32 minus the 27, that means we had to get 5 people that do both. Okay, does that make sense? Because we can only count, when you're doing these circles, you can only count each person in one spot. So out of the 18 people that take the bus, we figured out there was 5 duplicates that did bus and drive. So now if we subtract each of those, 18 minus 5 would be 13 people would do bus but not drive, and 14 minus 5 would give us 9. So 9 people would drive but not bus, 5 do both, and that's it. So when you're doing these kind of questions, the Venn diagrams are going to be huge to help you figure out how it's going to work, and then if you label them like we did here, we should have all of our answers. So the question that we were actually trying to figure out with this one is how many people do bus or drive. Okay, we already knew that sort of right off the first step. We went 30 minus 3 gave us 27, so we knew the answer was 27, but I wanted to show you the Venn diagram because there's a couple different ways of getting that number. So if we actually count up all of the circles, right, 13 plus 5 plus 9, that equals 27, right? 13 plus 5 is 18, plus 9 is 27, so that's good. Or the other way that we actually did it is we went 18 plus 14, right, that gave us 32, and then we would, so all of A was 18, all of B was 14, and then really all we have to do then is basically subtract the overlap. We don't want to count those people twice. So another way we could have done it is, once we had the circles, we could have went 18 plus 14 minus the 5, and that gives us 27. Okay, so that's basically an example showing the principle of inclusion and exclusion, and they're just two different ways of getting the same answer. It just sort of depends on which way your brain works better, which way makes more sense to you. A lot of people, I think, like the red version, just figure out all the circles and then you just add up all the sections. 13 plus 5 plus 9, that gave us the 27. But it also works to go 18 plus 14 minus the overlap. So whichever makes more sense to you, that's good. And that's really all the principle of inclusion and exclusion is trying to do for us. So these are the two formulas. There's two different ways of doing it. So what this one is saying is, in order to find A union B, we want to take all of circle A plus all of circle B, and then we subtract the overlap. So that's just like the last example we just did. The one here in blue is we did all of A, 18, plus all of B, 14, and we minus the 5. Okay, so I'll just kind of write that underneath so we remember what it is. So we did 18 plus 14. Oop, that pen's not working very good. Let's try that again. So 18 plus 14 minus 5 gave us the 27. Okay, and the second one that's listed here is basically what we did in the red. So let's just kind of look at the diagram again. So now this time, in order to find the union, the other option is take all of A without B, so that would be all of the A circle without the B, so that's sort of the Pac-Man there, plus all of the B circle without the A, so that's the other Pac-Man, and then plus the intersection. So we would do all of A plus all of B plus the overlap. Okay, and that's what we did on the last question too. That was the first way we did it. We went 13 plus 5 plus 9. So I'll write that in there again. 13 plus 9, and then the overlap was 5, and that gave us 27 as well. So that's what the principle of inclusion and exclusion represents. And like I said, that you don't really need to worry about the definition and understand how it works too much. Most people just sort of naturally would figure this out just sort of by using regular logic. So, and I would say probably in the times I've taught this course, most people tend to kind of do it the way we did in red. Just add up all the sections of the circles to get your total that way. That's it for today.